The basic spring-loaded pressure relief valve has been developed to meet the need for a simple, reliable, system-actuated device to provide overpressure protection. The following figure shows the construction of spring-loaded pressure relief valve. The valve consists of a valve inlet or nozzle mounted on the pressurized system, a disc held against the nozzle to prevent flow under normal system operating conditions, a spring to hold the disc closed, and a body bonnet assembly to contain the operating elements. The spring load is adjustable to vary the pressure at which the valve will open. Let's have a closer look. The following figure is a simple sketch showing the disc held in the closed position by the spring. When system pressure reaches the desired opening pressure, the force of pressure acting over area A1 equals the force of the spring, and the disc will lift and allow fluid to flow out through the valve. When pressure in the system returns to a safe level, the valve will return to the closed position. When a pressure relief valve begins to lift, the spring force increases. Thus, system pressure must increase if lift is to continue. For this reason, pressure relief valves are allowed an overpressure allowance to reach full lift. This allowable overpressure is in general 10% for valves on unfired systems. This margin, however, is relatively small, and some means must be provided to assist in the lift effort. In this regard, most pressure relief valves have a secondary control chamber or HUD-link chamber to enhance lift. A typical configuration is shown here. As the disc begins to lift, fluid enters the control chamber, exposing a larger area A2 of the disc to system pressure. This causes an incremental change in force which overcompensates for the increase in spring force and causes the valve to open at a rapid rate. At the same time, the direction of the fluid flow is reversed, and the momentum effect resulting from the change in flow direction further enhances lift. These effects combine to allow the valve to achieve maximum lift and maximum flow within the allowable overpressure limits. Now, because of the larger disc area exposed to system pressure, after the valve achieves lift, the valve will not close until system pressure has been reduced to some level below the set pressure. Actually, the design of the control chamber determines where the closing point will occur. Recall the difference between the set pressure and the closing point pressure is called blowdown and is usually expressed as a percentage of set pressure. Now, the design of the control or HUD-link chamber involves a series of design trade-offs, and it is important that you are familiar with them. If the design maximizes lift effort, then blowdown will be long. If, however, the design objective is to minimize blowdown, as seen here, then the lift effort will be diminished. So, keep in mind, many pressure relief valves are therefore equipped with a nozzle ring which can be adjusted to vary the geometry of the control chamber to meet a particular system operating requirement.